data center. What happened?
Why are you laughing?
So we built a large data center. The one side, the primary data center side, we try to use our install base of Catalyst product line on the Cisco side. On the newer data center, we have the Nexus 7000, the 5000 family on the other side. For the storage, we used thanks to EMC, I guess we used Clarion and VMAX as well. And on one side, we basically have the servers that we're going to move from the primary data center to the other data center. We did a couple of applications, and we will talk about what application we actually migrated over. For the actual interconnect part, we had actual fiber, as well as we had advanced simulation as well too. As the distance becomes longer and longer, we're running out of fiber, so we have to do some sort of advanced simulation there. But
one thing that's worth noting, right, is that we tested up to 200 kilometers, but that's where we stopped the testing. It didn't, there's more work to do to test it at broader distances, but there's nothing intrinsic in the stuff that we're talking about which stops at that mark.
Right. And let's talk about the one thing I want to highlight is on this particular solution that we used. We used the Catalyst 6500 VSS and the Nexus 7000 VPC on both sides. You were talking about the EMC VMAX look like one array. This is like these two switches look like one switch. So that allows you to actually avoid a spanning tree and blocked ports. Basically, that's one of the highlights of this particular solution there. So what exactly application that we used? We used what we feel as a real life, people use this kind of application. One is using Microsoft SQL Server, which is basically from the DVD store, open source benchmarking application. It really simulates an e-commerce website with people buying DVDs essentially, so many DVDs per second. And we did up to almost 15,000, 16,000 operations per minute, orders per minute basically. So it's a pretty highly intensive, I/O intensive application basically. And that's one of the reasons why we chose that. If it's a dead application we're moving, that's really not fun. I mean, that's not what you guys would eventually do. You want to move real applications across. The other application we thought was sort of mimics most of the customers. Some of the customers I talked to in the booth, they wanted to exchange Microsoft Exchange. One of the, I guess the common applications they want to move around. So again, we used a Microsoft Exchange Server 2007, and to generate the load, we used the load gen. Microsoft has a tool that they provide to simulate load test on the Microsoft Exchange. So we used lots of users, a lot of power users, and the idea is to see how well the VM performs as it moves across the data centers. So here's some results. So this is the SQL Server move by itself, and the x-axis is basically the distance between the data center that we simulated. So 0 to 200 kilometers. 0 being same data center where the applications are, the storage is local. Actually, let me clarify here. These tests are based on a shared storage model.
So 1A.
Yeah, it's 1A exactly. So in this case, the storage remains in the primary data center, and only the VM is moving, up to 200 kilometers away. And within the same data center, we saw about a minute of migration time. As you can see, it's a pretty heavy I/O operated, VM, so it took about a minute. And as we moved across over 200 kilometer distance, we saw the migration time, was still within the reasonable limits. I would call, less than 3 minutes of time as we move across. So it is possible to do that. This is without no acceleration. I want to make sure people understand that this is with no acceleration. If you add in acceleration, you may be able to shorten it. The second thing we want to do is, okay, now the VM has moved over. How is the performance with the shared storage? The storage is still sitting in the primary data center, and we want to see how does the shared storage model work, which is 1A again, where we used our Cisco MDS solution for the SAN part. And if you remember the diagram, we had MDS for our SAN extension part. So in this case, we used fiber channel over IP. We also did native fiber channel, We also did fiber channel over IP, and also we added a kicker, which is a fiber channel over IP with I/O acceleration. So MDS has a feature which allows you to cut down the round trip time when you do each I/O across the data center. So we did that, and we saw that the performance didn't drop dramatically at all. We actually, to our surprise, we saw only about 12% drop in I/O performance. So how are we measuring the performance? We're measuring based on the number of orders per minute that particular SQL server is performing. While it is in the local data center, as you can see, it's about 15,000 orders per minute. And as it moves across the longer distances data center, we're still able to keep up the performance with this with our solution.
And again, the key thing here is the reason it declined is that even with all the technologies that exist, there's still a little more storage latency, right? So if it was 6 milliseconds when it was all on one site, and then it's basically 10 milliseconds after you add in the extra distance latency, it's going to decrease. One thing that we actually didn't do ourselves a favor here is note that the scale isn't 0 to 1500, right? Because if you actually scale it out linearly, it's surprisingly flat, even with that additional latency added in.